Hi, I'm Harish Iyer. I'm a solutions architect with AWS. Today, I'm going to show you how you can use AWS services and a Raspberry Pi to build a smart baby sleep assistant. Newborns tend to sleep 16 to 18 hours a day, waking up every 2 to 3 hours in between. Until they learn to go back to sleep by themselves, most of these sleep interruptions require some level of parents' involvement. The smart assistant lends a hand to parents during these demanding times through monitoring, automation, and analytics. This is a fun project to get your hands dirty on areas like Internet of Things and machine learning using AWS services. So let's get started. The smart assistant has three key features. First, it continuously monitors the baby while sleeping and detects when the baby wakes up and starts crying. It then takes specific actions based on how you configure it to help the baby go back to sleep. If it's not successful in doing that, it also alerts the parents for attention. The third feature, and perhaps the most important one, is analytics. The smart assistant collects and stores data on babies' sleep events and uses that to build insights on babies' sleep patterns. Let's see this in action. Here is the baby room setup. I'm using a regular swing with a plug-in option, and it's attached to a Wi-Fi connected plug. I also have a lamp in the room with a smart light bulb. I'm also using an external speaker which is connected to the smart assistant. And here is a smart assistant. It's a Raspberry Pi with a motion sensor, a camera, and a USB microphone attached to it. I've connected this smart assistant to the swing and set it up closer to the baby. One last step in the setup process is to use a mobile app to configure the smart assistant setting. Here, you can choose what actions to take and how long. Once the setup is complete, the smart assistant starts monitoring the baby and detects if there is a movement or a crying sound. And when that happens, the automation kicks in. The smart assistant starts the electric swing and starts the video recording of the event. It also plays music or sleep sounds through the external speaker. Now, these actions continue for a default of 2 minutes or whatever period that you configured through the mobile app. If the baby is still awake after that period, the smart assistant goes into escalation mode and alerts the parents. Let them know that the baby needs their attention. It also turns on the light in baby's room before the parents come in. Now let's take a look at the analytics features. Parents can use a mobile app to view the history of baby's sleep events, and they can also see the recordings of the events. They also get a daily report from the smart assistant through email. For this prototype, the email report includes 3 data points. The first one shows the number of times the baby woke up on a day-to-day basis. So if there is a significant deviation on any specific day, parents can see what's going on. The second one shows the effectiveness of the smart assistant. The green section in the pie chart shows the percentage of times the smart assistant was able to help the baby go back to sleep without alerting the parents. So if you're a parent, the bigger the green section is, the more time you get to sleep. I'm also including a detailed daily breakdown of the smart assistant performance, which can be used to tweak the settings and see the impact on baby's sleep. Now that you have seen the demo, let me walk you through the architecture. The physical device is a Raspberry Pi, and it has a motion sensor, a camera, and a USB microphone attached to it. Rest everything happens on AWS Cloud. To interact with the motion sensor and the camera, I'm using a managed IoT service called AWS IoT Core. And to build the end-to-end workflow for the smart assistant, connecting these devices and AWS services, I'm using AWS IoT Things Graph, which allows me to do this visually. Now, how do we know if the baby is actually crying or making sounds while playing? For this, I'm using Amazon SageMaker. SageMaker lets you build, train, and deploy machine learning models quickly. For cry detection, I'm using a custom audio classification model using SageMaker PyTorch framework. When it comes to actions, some of these are API based, like turning on the swing, etc. For calling these APIs, I'm using a Python function which runs on AWS Lambda. Lambda is a serverless compute service. And to alert the parents through text messages, I'm using a managed multi-channel communication service called Amazon Pinpoint. When it comes to storing the data, I'm using Amazon TimeStream. TimeStream is a serverless time series database which is ideal for storing IoT events like the sleep event data. And to build the reports and dashboards on top of the TimeStream data, I'm using Amazon QuickSight, which is a managed business intelligence service. The last part here is a mobile app. For this, I'm using AWS Amplify. Amplify lets you build and deploy secure, scalable, full-stack mobile applications quickly. What I like about this architecture is that it's serverless. There are no servers to provision or manage. AWS takes care of scaling these services based on the demand. And the best part, you pay only for what you use. Before I let you go, I want to share a couple of thoughts on how you can make the smart assistant smarter. First, the AWS IoT services lets you interact with a number of smart devices and sensors. So you can use them to collect more data and take actions based on them. For example, you can have a temperature and humidity sensor in baby's room and use that to determine the ideal ambient conditions in the room and control a smart thermostat based on that. You can also collect data on diaper changes and feeding and let the smart assistant alert you if there is a significant deviation from the regular routine. The other thing is, for this prototype, parents need to use a mobile app to configure the smart assistant setting. What if the assistant learns to tune itself based on how effective it is in helping the baby go to sleep? We are already collecting all this data. So it's a matter of feeding that into a machine learning model, which can make the recommendations. That's it. I hope you found this session interesting and it gave you ideas and inspiration to build something similar on AWS. Thanks for your time.